this tutorial, we'll go over logical equivalences involving conditional statements. What is a conditional statement? Remember, P implies Q. This implication means it's conditional. Let's actually start off with the P implies Q. When you're doing proofs, you try to get rid of this implication with all your might. P implies Q is equivalent to not P or Q. There's no real simple trick that I can give you that goes from here to here that you can remember. The only way we could really look at this if we look at the truth table and see if they are equivalent. So we have PQ, we have not P, we have P implies Q, and not P or Q. So true, true, false, false, true, false, true, false. The negation of P is false, false, true, true. P implies Q. True implies true is true, true implies false is false, false implies true is true, and false implies false is true. Next we look at not P or Q. So we look at these two columns. So false or true is true, false or false is false, true or true is true, and true or false is true. So as you can see, the columns are identical. This is the one that I use most frequently. Whenever I see an implication, I instantly turn it to this, not P or Q. So you'll just memorize it and it'll just stay there. P implies Q is also equivalent to not Q implies not P. If at any one point you see a not Q implies not P, just know that that is P implies Q. You can take it back to this and then do your other operation with the negation and the disjunction, or you can actually go from here and you can negate this entire not Q or not P, which comes out to Q or not P. It's the same as this right here. Remember our commutative law? We could swap this to not P or Q. Same exact thing. Next one we're going to look at is P or Q. Well, that's equivalent to not P implies Q. Sometimes the situation arises where you gotta go from pure Q to not P implies Q, but most of the times you just want to recognize that this equals this. And if you don't remember this, I mean, just remember that P implies Q is identical to not P or Q, so then you can just work it out right here. So you can say not P or Q, which is P or Q, which is identical to that, right? So same exact thing. Let's move on to P and Q. Well, that's equivalent to not, and then in parentheses, P implies not Q. Well, how is this identical? Well, let's go ahead and work it out. Let's see what happens. We'll keep this not right here for right now. Let's get rid of this implication symbol. So remember, not P or Q. That comes out to not P or not Q. The not was already there, so we just keep it there. And then we distribute this not inside here. That comes out to P and Q. The negation of a negation is just P, negation of negation is just Q, and you swap the symbol. That comes out to P and Q, which is equivalent to this right here. The next one says that P implies Q and P implies R is equivalent to P implies Q and R. So this is actually kind of straightforward to see. If P implies Q and P implies R, then P implies both Q and R. So which is stated right there. P implies both Q and R. Well, let's go ahead and see if we can get these to be equal to each other, right? So let's go ahead and get rid of these implication signs. So let's say not P or Q and not P or R. And let's see on this side, we'll say not P or Q and R. So if we distribute this not P inside here, that comes out to not P or Q and not P or R. And guess what? We rewrite this down here, not P or Q and not P or R. You'll see that this side is equivalent to this side. Alright, the next one is P implies Q or P implies R. Well, that's equivalent to P implies Q or R. So if P implies Q or P implies R, then either Q or R are implied by P. Just listen to that sentence a couple of times, I think it will make sense. But if it doesn't, let's go ahead and do the same concept down here. Make sure we get it right. Not P or Q, or not P or R. Well, that's equivalent to not P or Q or R. Well, what does that come out to? It comes out to not P or Q or not P or R. If we bring this down, you'll see that both of these are actually equivalent. Now, just for fun and for practice, we'll go ahead and continue on with this one just to see kind of where we get. You'll see that all of the symbols are OR on both sides. So what does that mean? Well, that means we can swap these around using our associative law. So we can say swap these two around, Q or not P, or we can even take this out right now and just keep it out. And then let's go ahead and do this. Q or not P or not P or R. Well, what does that come out to? That comes out to Q or not P or not P. Well, that's just not P or R. How did I get this not P from the not P or not P? Well, take a look at the idempotent law from my previous tutorial. And the same can be done on this side, since they are identical equations, so that would come out to Q or not P or R. The last one for today that we're going to focus on is P implies R or Q implies R is equivalent to P and Q implies R. If P implies R or Q implies R, well then both P and Q imply R. Now let's take a look at a little proof real quick. So not P or R or not Q or R is equivalent to P and Q implies R. We'll start off with this one next. Let's go ahead and see what this comes out to. This implication symbol is right here, so we'll treat this entire parentheses as a variable. So we'll say not P and Q or R, and then we'll go ahead and distribute this within the parentheses, so that comes out to not P or not Q or R. Now let's see if we can simplify this. Well, here's our commutative law again. All the symbols are OR, so we have R here and an R here, so technically we can write this as not P or R or R or not Q, and then we can continue on with not P or R or not Q, and this simplifies to R, so not P or R or not Q. Well, it's just a matter of swapping these around, so we can say not P or not Q. We'll go ahead and swap these two around, or R. And as you can see, these two are, as a matter of fact, logically equivalent. So we'll end this tutorial here, and in the next tutorial we'll move on to logical equivalences involving biconditional statements. Make sure to subscribe for your daily discrete math tutorials.